Today we are going to talk about periodic table again, and we are going to differentiate the old periodic table and modern periodic table. Old periodic table is also called Mendeleev periodic table. What are the differences between Mendeleev periodic table and modern periodic table? We are going to differentiate them. Okay, now let's have a table. Left hand side Mendeleev periodic table, right hand side modern periodic table. First point, we can say that the elements were arranged in the order of increasing atomic weight in Mendeleev periodic table, old periodic table. But in case of this modern periodic table, elements are arranged in the order of increasing order of their atomic number. Now let's have the old periodic table and modern periodic table, and then this point can be understood. In this case, this is the Mendeleev periodic table. Here elements are arranged in the increasing order of their atomic weight. Lithium atomic weight 7, beryllium 9, boron 11. In this way, carbon, nitrogen, oxygen, fluorine, etc. In another row also the same. In this way, all these elements are actually arranged by Mendeleev in the increasing order of their atomic weight. But there's different concept in modern periodic table. These elements are here also arranged, but in the increasing order of their atomic number, not according to atomic weight. Now let's have the table again. Second point, there is not a fixed position for lanthanides and actinides. But in case of modern periodic table, it provides a fixed place for lanthanides and actinides. Let's have a look on Mendeleev periodic table. This is the developed form of Mendeleev periodic table. And looking at this table, there is no any lanthanides and actinides placed in this table. Lanthanides and actinides are not included in the old periodic table, but in case of modern periodic table, the lanthanides and actinides are added at the bottom of the modern periodic table. They are present at the bottom. Now let's have the look on the table again. Third point, there were 7 periods and 8 groups of element in Mendeleev periodic table, but there are 7 periods and 18 groups of elements in what modern periodic table. Let's have the table again. Look at this. The elements which form vertical column of the periodic table is called group of periodic table. Here we have 1, 2, 3, 4, 5, 6, 7, 8 groups, and the elements which form the horizontal row of the periodic table is called this period of periodic table. Here we have 7 period. This horizontal rows represents the period. In this case we have 8 group and 7 periods. What about modern periodic table? Look at this. Here we have 18 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Here we have 18 vertical column of the elements. That's why it has 18 groups. These two, lanthanides and actinides, are also included in the modern periodic table. In the same periodic table, after lanthanum we have lanthanides, and after actinium we have actinides. Look at this. After 57, here it is written 72. From 58 to 71 comes at this place in 6th period, and from 90 to 103 here. After 89, 90 to 103 comes in 7th period. That's why we have 7 period but 18 groups in modern periodic table. Now let's have the table again. Another difference, we can say that position of isotope was not clear. Isotope means the elements having same atomic number but different atomic weight. Just for example, hydrogen has got 3 different isotopes: protium, deuterium, tritium. And protium has got 1 atomic number, deuterium also 1, tritium also 1, but atomic weight of protium is 1, deuterium is 2, and tritium is 3. And all these 3 are not included in the periodic table. Hydrogen is included because its atomic number is 1, and elements are arranged in modern periodic table in the increasing order of atomic number. That's why only hydrogen is taken, not deuterium, not tritium. That's why we can say that isotopes were not taken in the table because elements are arranged in the order of increasing atomic number but not according to atomic weight in case of modern periodic table. Now let's have another point. In the place of one element, there were two or three elements. Here, each element has its own place in the periodic table in a series. Now let's have the periodic table again. This is an old periodic table. In place of one element, in certain places there are two elements. Look at this, two elements are placed in place of one element. Here also two, here also two, here also two. Some places there are three elements also instead of one: iron, cobalt, nickel here. In this way we can say that position of each of the element is not particular in this periodic table, but in this case, modern periodic table, each element has got its own place. Okay, let's have the table again. Now, sixth point. Elements were divided into groups and periods only in old periodic table. But in case of modern periodic table, elements are divided into groups, periods and four distinct blocks, that is S block, P block, T block and F block. Let's have a look on the periodic table. Here, elements are divided into these 8 groups and 7 periods. Only groups and periods are declared. But in this modern periodic table, not only the group and period, this 1A, group 1A and 2A comes under S block element, and group 3A, 4A, 5A, 6A, 7A and 0 comes under P block element. This is one of the block, S block. This is another block, P block. And the main part of the periodic table, the middle part, represents D block. It starts from 3B, 4B, 5B, 6B, 7B and 8 and 1B, 2B. They comes under D block element. And this is F block element. Which one? Lanthanides and actinides. They comes under F block element. That's why in modern periodic table, elements are not only divided into groups and periods, they are also divided into 4 distinct blocks. Okay, let's have the table. These are the important differences between Mendeleev periodic table and modern periodic table. Only 6 differences I told you. There are many other also, but these 6 are very important. Okay, now I want to stop.